Hello, Coach Holmes here, and today we're going to be talking about using Pythagorean Theorem to find length in three-dimensional figures. Now, you're probably thinking, well, how is it possible that we can use Pythagorean Theorem for it? Well, part of it is just knowing the imaginary lines on a three-dimensional figure. So, for example, if I look at this cone, initially, I see a triangle. I can see a triangle going this way. Let me change the pen real quick. If I do this, I can see a triangle. I can see a triangle going like this, but where's the right triangle? Well, if I go from the vertex down, there's my right angle. Therefore, I have a right triangle. And of course, anytime we use a right triangle, we can use Pythagorean Theorem. Now, same thing over here, just another example. So imagine if I were to go straight down, like this, and I make another right angle. Okay? That will work as well. Okay? So I can find the height, pretty much the height of this triangle using Pythagorean Theorem. Also, if I were to imagine this triangle right here, if I were to go straight down, but it's going to land somewhere right here, or I can go across like this. Okay? So I can go straight down across to the center of that base. And I can go from this vertex to the side to find the height of the base right there. So there are different ways of being able to find length. We just got to be creative enough with the imaginary lines we have in order to find right triangles. Now, just to find some examples in order to find the length. So, for example, I want to find this x right here. Well, first off, this diameter gives me 12. But imagine that this is dead center of the base. Okay? So if this is dead center, that means it cut it half. So half of 12 is 6. So I have the length of 6 here. Now, in order to find this, I got to do 8 squared plus 6 squared equals c squared. Or, better yet, x squared. Considering that's what we're looking for. Now, 8 squared, that's going to give me 64. 6 squared gives me 36. So then, I add these two together, take the square root, x is going to give me 10. So x is a length of 10. Now, what about number 2? Well, this is a pretty simple one, except for the fact that this length right here is 26. But more likely, they're going to be the same length. They're going to have the same base, considering these are all rectangles here. Because I imagine that this being a rectangle, this is going to be 26 as well. So we should be able to find the length using Pythagorean Theorem. So that means we're going to have x squared plus 24 squared equals 26 squared. Now, 24 squared is 576. 26 squared is 676. Subtract the 2. So I want to subtract 676 from 576. X squared equals 100. Take take the square root of that. X is going to give me 10. So it's just a coincidence that two problems are the same numbers. But this time go around, we have the hypotenuse for that base. We just need to be able to find the length of the legs. So next, I want to look at number 3. So we have this length right here to be 10, and it's kind of hard to see. This length is 4. Okay, so we want to find this slant height right here. That's what we're looking for. We're looking for the slant height now. So, now, but notice I want you to see that we have the original height here for the pyramid, but we also going from one at the edge of the base to the center where the height hits. Okay, we actually said that knowing that it's going to be a right angle, considering the height is vertical, straight up and down. All right. So we have this triangle right here. Now, so we want to find x here. So that means that my two legs are 10 and 4 equals x squared. So 10 squared gives me 100 plus 16 equals x squared. So 100 plus 16, that gives me 116. Take the square root. And x is going to give me 10.77. All right. So even with something like this, I should be able to find and make a right triangle. And that's really what the goal is, be able to make those right triangles. So now, this time we have something that's upside down. So this 20 right here, this 20 is my height. This x right here is my slant height. And now this edge here is 10 meters. All right? Now imagine if this was cut in half still. We want to take half of 10, which is 5. So I should be able to, again, use Pythagorean Theorem to help me solve. So if we set it up, we're doing 5 squared plus 20 squared, since they're both the legs. This slant height is my hypotenuse in this situation, so I'm going to make it x squared. So 5 squared is 25, 20 squared is 400, 400 plus 25 is 425, and the square root of 425 is 20.62, rounded up. So the biggest thing that we got to be able to do is that we got to be able to make imaginary lines in order to make right triangles. Because situations like when we need to find the slant height or the regular height, we got to be able to do Pythagorean Theorem in order to find those lengths. Okay? So it is important to make imaginary lines in order to make right triangles to use Pythagorean Theorem to help us find either things like the slant height or the actual height. Thank you and have a good day.